Good morning, guys. So today we'll be looking at concentration of solutions. We're going to see how can we determine how much of a substance is present in a solution. So it is important for us to be able to always know the amount of substance present in a solution if we're trying to understand solution stoichiometric. Okay, so concentration of solution. Okay, so the first thing we have to understand is when we speak about the concentration of a solution, we're normally talking about molarity. So, molarity, and the symbol for that is big M, also called molar concentration. So, there's a formula we use to determine the molarity of a solution. Molarity is equal to the moles of solute over the liters of solution. So I hope by now we all know what is meant by the solute and the solution. But just a recap. So let's say we have a salt solution, that is salt dissolved in water. The solute would be the salt, and the solution would be the end product. The solvent would be the water. So we would put our salt, or aka the solute, into our solvent, the water, and when everything is dissolved and mixed up, what we have is the solution. So when we talk about the molarity of a solution, we're talking about the moles of solute over the liter of solution. Okay, so we will have to, in order to work these questions, we have to understand a few conversions. So normally you're given, most questions will give you milliliters. So they'll give you like 250 milliliters. And if you're going to convert that to liters, you'll have to divide by 1,000. So it's going to be 250 over 1,000 to be equal to 0.25 liters. Right. Also, you need to be aware of another way to, sometimes you'll be asked to determine the number of moles. So moles is also equal to the mass in grams over the molar mass. That's another formula which you should have been aware of before. So let's look at this question. So I'm going to write this question and we're going to tackle this question. So the question goes, how many grams of potassium dichromate For those of you familiar with potassium dichromate, you will know this is a powerful oxidizing agent. That's the formula used to represent potassium dichromate. So are required to prepare a 250 milliliters solution whose concentration is 2.16 big M. So what is the question asking us? The question is asking us to determine how many grams of potassium dichromate are required to prepare a 250 milliliter solution whose concentration is 2.16. So the first thing we have to see, what do we have and what do we need? So how many moles of potassium dichromate does a 1 liter solution contains? So we have a 2.16 molar potassium dichromate solution. Right? So the first step is to determine the number of moles of potassium dichromate in 250 milliliters. So that's the first thing we're going to do. So first step, determine the number of moles of potassium dichromate in 250 milliliters. Of course, 250 milliliters we found out is the same thing as 0.25 liters. 50, let's put a 0. So before we remember before we have our formula, molarity is equal to moles over liter. We can do some rearrangement if we want to determine the number of moles. So we're going to end up with moles is equal to molarity times liters. So our molarity here, we're given the molarity. Let's check back. The molarity is 2.16. So that's 2.16. That's our molarity. And we have 0.250 liters. So this tells us that the number of moles will be equal to, that's 2.16 times 0.250. If you were to work that out, you're going to get 0.540 moles of K2Cr2O7. So now we have the number of moles. We can determine the mass in grams. Because remember we found out that number of moles is equal to mass in grams over molar mass. So we have the number of moles. We can easily determine the molar mass. So then we can get the mass in grams. So again, we can rearrange this equation to have mass in grams will be equal to moles times molar mass. So the number of moles we found it out here. So number of moles is 0.540 moles. and the molar mass. So to determine the molar mass, you need to look at the formula of the substance you have and to add up all the mass numbers. So our K2Cr2O7, if you use your reference table, you're going to realize that K2Cr2O7 has a molar mass of 294.2 grams. So our mass in grams then, our mass in grams will be equal to 0.540 times 294.2, which will give us 159 grams of K2Cr2O7. So you're going to get a chance to try this on your own or a similar one on your own.